Hey guys, welcome to the next video on OpenCV tutorials for beginners using Python. In the last video, we have seen how we can use Harris Corner Detector in order to find out the corners inside an image. In this video, I'm going to show you how you can use Shi Tomasi Corner Detector method to detect the corners inside an image. So in late 1994, J. Shi and C. Tomasi made a small modification in the Harris Corner Detector method in their paper, which was called Good Features to Track. So this Shi Tomasi method is similar to Harris Corner Detector apart from the way the score of R is calculated, which we have seen in the last video. So this Shi Tomasi method gives us better result in comparison to Harris Corner Detector, and also when you use this Shi Tomasi method, we can find the top n corners, which means we can provide the number of corners we want, and this might be useful in cases where we don't want to detect all the corners inside an image. So let's see in the code how we can implement this Shi Tomasi Corner Detector in OpenCV. So here I have already written all the code. So let me explain you all the lines of the code one by one. So as you can see here, I'm just importing the libraries in the first two lines, and in the next line I'm just reading the image using imRead method, and then I'm converting this image into a grayscale image using this CVT color method. So I'm converting this image from BGR to grayscale image. Now, as I said, the paper which was published by Shi and Tomasi was named Good Features to Track. That's why in OpenCV, this method is also called Good Features to Track. So here in this line, we are just using this method cv.goodFeatures to track, which takes few arguments. So first argument here is our input image, which is a grayscale image, which we are providing as the first parameter. The second parameter is the maximum number of corners. So here we can limit the number of corners we want to detect. So for example, I have given 25 here. That means we just want to detect 25 corners, and if there are more than 25 corners which are present in the image, they will not be shown. So this value means maximum number of corners to return, and if there are more corners than the corners found, then the strongest corners will be returned, right? Now the third parameter here is called the quality level. So this is the parameter characterizing the minimal expected quality of the image corner. The next parameter here is the min distance, which is the minimum possible Euclidean distance between the returned corners. So I have taken 10 here as the minimum distance and 0.01 as the quality level. Now once all the corners are detected using this Good Features to Track method, we convert those corners into the integer values, and here int 0 is a mere alias for int 64, and once all the corners are detected, we iterate over all the corners, and then we find out the value of x and y using this I, and then it's easier to just draw the circles over these values using the cv.circle method. So this cv.circle method takes few arguments. First is the input image. So the second parameter is the center. The third parameter is the radius of the circle which we want to provide. The fourth parameter is the color we want to provide, and the fifth parameter is the thickness, and if it's -1, that means we want to fill the color inside that circle. And at last, once all the circles are drawn on the corner which are detected, then we are just showing this using IamShow method. So let's see how this works in the case of Shi Tomasi method on an image. So I'm going to run this code so you can see all the corners inside this image are detected. And because we have just provided this number 25 here, so maximum number of corners which will be detected here will be 25, and rest of them will not be shown. So if we increase the value of the maximum number of corners, let's increase it to 100, let's say. So I'm going to just increase it to the value 100. You will see more number of circles are drawn on an image. Now let's compare the result of the Harris corner detector and Shi Tomasi corner detector. So on the left hand side you can see the original image, and this middle image shows the Harris corner detector method, and you can see all the corners are detected using Harris corner detector. And using the Shi Tomasi corner detector, it gives us better result, and we can control the number of corners we want to detect. And you can see all the important corners are detected using Shi Tomasi corner detector in a better way. So that's how Shi Tomasi corner detector works. I hope you've enjoyed this video, and I will see you in the next video.